Hello everyone, my name is Keane and I'm a PhD candidate at the National University of Singapore. I'm also doing my PhD research with MIT, and today I am presenting to you a paper which was accepted by Association of Computational Linguistics, and it is called Towards Robust ESG Analysis Against Greenwashing Risk. So I just want to dive into what we'll be talking about today. So we'll be introducing the problem, we're talking about contributions in terms of the data set that we have, as well as the experiments, and I'll also be touching on key points for future research. So the problem that we have, just to give a larger background to the issue, it has to involve NLP-driven ESG analysis. So as you know, we have, or there's a lot of publicly available ESG data. And a lot of this ESG data is actually frequently scrutinized by regulators, investors, and the public, where they frequently extract and synthesize insights. And recently there's talk of AI trying to automate some of these processes. However, AI has roughly focused on the sophistication of data, meaning just automating and aggregating insights from the large volume of data. Whereas we argue that, ESG analysis should encompass more than just like automating analysis and trying to synthesize insights from a large volume of data. It has to go hand in hand with actually addressing some of the more pertinent issues at hand with ESG analysis. And these are more frequently related to greenwashing, such as, deliberate incompleteness of data, the unreliability of data, the ambiguity involved in some of this data. And we actually termed this under the subjectivity challenge, which was done in a survey paper that we did previously, but won't go into that in too much detail. I have attached a link if you wanna try to discover more about what this survey paper is trying to argue as well. But the crucial insight is that while a lot of these existing NLP tools have focused on automating some of the insights, they have lacked robustness against some of these greenwashing related or greenwashing associated challenges in terms of ESG content. So just a few examples, ESG Sentic Net as well as ESG Reveal, they frequently emphasize on aggregating, very broad insights with retrieval augmented generation or just topic analysis. But it doesn't really deal with, the credibility of the claims within some of these specific sustainability reports. And where we would like to come in with this data set is to explicitly address, some of the credibility of claims involved by, offering a new data sets which address robustness against some of these greenwashing or greenwashed content. So I just want to expound on this idea a little bit more with the new or novel problem setup that we have. So it is called aspect action analysis with cross-category generalization. So essentially, the idea is that within our problem statement, we would have a sustainability statement such as this, and the crucial task for the algorithm is to understand and extract what is the aspect within this sustainability statement, as well as to classify the action taken towards it. So you can see here that the action taken towards the specific aspect of carbon emissions in this statement is planning, meaning that the company is planning to deal with the carbon emissions next year. And beyond this, there's also other action labels such as indeterminate when some of the statements are more rhetorical and they emphasize less concrete actions and things like that. So the idea is for the computer science or like NLP algorithm to try to extract some of these crucial aspect and action pairs. So it's draw some inspiration from aspect-based sentiment analysis. And to not only do that, but to be trained on scene categories, meaning categories of sustainability statements such as carbon emissions or outreach, which deals with the social segment of ESG, and to be tested on in a cross-category generalization setting to unseen categories such as statements under waste management, statements under workplace, which it hasn't seen before. So just to recap, because there's a lot of things to unpack here. The idea is to classify actions towards sustainability aspects and to generalize toward unseen categories omitted from training. So in this way, we argue that there's better robustness against greenwash contents because it addresses two things which are common with respect to the challenges that we've seen earlier. So first it counters changes in reporting patterns when companies try to try to alter their sustainability reporting to emphasize some of their key sustainability areas, whereas they try to omit or they try to hide some of the areas that they're not performing well in. And the second thing is to clarify genuine initiatives from rhetoric by offering this granular form of analysis as opposed to topic analysis and retrieval augmented generation that we've seen previously, as I discussed. So the idea, is not to just offer this data set, but to analyze, the shortcomings of existing models. So what we did was we had two groups of models, so supervised models as well as large language models. So supervised models, we're just referring to PLMs or pre-trained language models. And these are actually based on the BERT architecture. So we take existing aspect-based sentiment analysis models, we do some form of supervised learning. The other form of analysis, other form of models that we're also surveying is large language models, where we primarily use prompting methods with no additional fine-tuning. So we try to put them through these different subtasks as well as this combined task that we have. So aspect, term, and extraction and action classification, I think I briefly covered that, as well as aspect action analysis. And we see some of the results here. So we see that actually supervised models generalize better than LLMs for the joint task of aspect action analysis. And in addition to this, what we also see is that when we compare the subtasks of aspect term extraction as well as action classification, the models find action classification much more challenging compared to extracting aspect terms. So through our analysis, we realized that by looking at the qualitative failure cases, there is a lot of linguistic challenges with this particular subtask. There's a greater emphasis on interpreting the pragmatics of the sentence as well as the syntax. Some other insights we have also deal within the supervised models as well as the LLMs itself. So for supervised models, we actually also set up a baseline of comparing contrastive learning techniques with respect to adversarial learning techniques using both BERT sequence tagging as well as the T5 generative model. And through these very simple baselines, we observe that the performance for contrastive learning is much better than adversarial learning. And we also try to have like a greater granular analysis of the sort of embeddings and the features produced by both of these methods. And we realize that contrastive learning has cleaner separation of features, which actually aids some of the generalization performance, whereas adversarial learning appears to have features which are closer together, so features which appear less distinguishable. And we argue that, okay, although future work is needed on this, we feel that this might be counterproductive, where you are still trying to generalize from a close distribution, cross-category instead of cross-domain, for instance. So we also unpack, some of the shortcomings of large language models, and we realize that they have some potential biases involved. So there is a higher recall, for aspects in environmental categories, as you've seen from this chart. So model tends to do better in terms of extracting aspects from environmental categories. And there is, this might be linked to some of the pre-training biases. So for instance, we have surveyed some literature and we found that a lot of the ESG-oriented analysis that many different people talk about online is environmental as well as it's basically environmental out of the ESG pillars. And this might actually manifest itself in the form of pre-training biases, where large language models tend to perform better to data patterns with greatest popularity. So in short, so this is quite a short presentation. So just to recap, we argue that NLP needs to address all of the challenges for ESG analysis. No, it shouldn't just be automating some of the sophisticated or very large volume of data involved. It should address other greenwashing problems as well. So we believe, having this data set could be a first contribution in this direction. And we have also made this data set publicly available as well as our code. And we ask, researchers, encourage them to address some of these problems in Totem by using and leveraging this data set. So we have attached like a GitHub as well as a paper as well. So just wrapping up my presentation, just to give thanks to all the support from my lab as well. And you can see some of my lab mates that we have, and as well as some of the links.